Okay, ladies and gentlemen, we're watching video 9.2 for lesson 9.2, Simplifying Square Roots, and I found a little humorous picture that I am using. This is a root, and I have the little saying that I found, looks like we found a square root. Isn't that funny? Ha ha ha, laugh a little bit, right? Okay, I know I'm corny, but we need to be taking some notes. Make sure you're doing that. And the video word or the magic word for this video, or the thing I want you to let me know that you watch this video, is going to be the square root joke. Was so funny. If you'll put that in a box and put video around that, the square root joke was so funny. It'll just make me smile at least, okay? All right, so the product property of square roots is saying the square root of a times b is the same as the square root of a times the square root of b, so long as a is greater than 0 and so is b greater than 0. You can use the product property of square roots to simplify radical expressions. Radical expressions in simple form where no factor of the expression under the radical sign has any perfect square factor other than 1. There are no fractions under the radical sign and no radical sign in the denominator of any fraction. Okay. So we're looking to get all the perfect squares out, and we don't want to see fractions, square roots with fractions, and fractions with square roots. Okay, so let's go ahead and go to the next. If you need to pause that, please do. We have the square root of 675 equals the perfect square of 225 times 3. This is where your list that you created in the last video will be helpful. So if you have not done it, you're going to want to, because this is not going away. And especially since you keep hearing me talk about it, I hope you know that when I say that, you know it's going to keep coming back. Okay, so we have the square root of 15 times 15 times 3, because 225, the square root of 225 is going to be 15, so 15 times 15 times 3. Well, since I have two 15s under the radical, I can bring that out. So I have 15 radical 3, or 15 square root 3. Now, I want you to notice this piece that I'm highlighting right here, and I'll take that off so you can actually see it. This part can be challenging. It takes some guess and checking to determine the perfect pair that's going to work. You have to use your list to help you determine those perfect pairs. Remember, we're multiplying, no adding. Everything has to be multiplied. Because you might say, well, if I have 400 is a perfect square because it's 20 times 20, and then I can just add 275. Nope, can't add. Cannot add. You have to multiply everything. This is why it's going to be challenging and take some time. Okay, let's go to the next one. We have the square root of 176 multiplied a squared is going to be equal to 16 times 11 are factors of 176 times a times a. You're looking for factors. Maybe you can see a perfect square in it, maybe not. You can work through if you take them down into the basic factors. That is one method of solving. So I see that I have 16, so that's a perfect square. So I get 4 times 4, e times 11 times a equals. Well, I have two 4s, so I can bring one of those out for my square root, and then a times a, so I have 1 for my square root. So I have 4a is times the radical 11. Again, I have this notice because it really is challenging. I want you to remember that it's going to take some time. If you take things down to the factors, though, you're going to see, oh, I have 1 4, 2 4s. Oh, I have this many of that. It may help you when it's not easy to see. Remember, everything is multiplied. There is no adding. Okay, let's go to the next slide. Go ahead and pause if you need any time to copy things down. We have the square root of 49 divided by 121 multiplied to x squared equals, well, what are my factors of 49? 7 and 7. That was pretty easy. What are my factors of 121? If you have that list, you know immediately, even if you don't know your factors of 11, and it's 11 times 11. And my factors of x squared is x times x. So I'm simplifying. I have it down to 7 divided by 11x is my answer. Remember, everything's multiplied. There is simply no answering, and I know you're going to be so disappointed, but this is the last slide in 9.2. Thank you.